So when you basically like do the quadratic equation, now for example, um, if I solve a particular equation, ax squared plus bx plus c equals to 0. Now what we take is, in this quadratic, we use the formula negative b plus or minus root b squared minus 4ac over 2a. Now what actually these represent are basically they are the roots of the quadratic. So now when you sketch a quadratic, let's say, we'll just touch base upon how to do the sketching and all as well in later part of the lesson. But just now, suppose let's say a quadratic cuts the graph at 2 points. Now when you say it cuts at 2 points, basically this part is something as the first root and this is the second root. This root is basically, you can say, negative root b square minus 4ac over 2a. That's your one root. And other root is negative b plus root b squared minus 4ac over 2a. Now, what's the most important part that decides whether the graph is cutting at 2 points, whether the graph and x-axis are intersecting at 2 points, or there might be a case where the graph is basically, it's like here. So the graph is just above x-axis. In this case, the graph is not cutting at any point. So there we'll talk about this, like what might be the reason that it does not have a root, or it can be something like here. The graph is let's say entirely below x-axis. So this case, you can see that as the graph is not crossing x-axis at any point, we call this as a zero root. Zero root. Now here what we have is, we have got, like, we can say that this is the two roots. The two roots that are distinct roots. And so what is the thing that is not, like, I mean, not the same as this graph? So number one is, when you look at a quadratic, uh, this formula, the decider is this part, which is root of b squared minus 4ac. Now root of b squared minus 4ac, if I pick up a number, root of negative 8, you can say that the solution to this equation is non-real. Non-real. So root of minus 8, you can't find out with the real number system. So whichever equations are basically giving this inside the root number, negative. Like for example, if b squared minus 4ac is negative, which means that less than 0, they are not going to cut x-axis at any point, because your root of negative numbers does not exist. I mean, which is non-real. So in that case, your graph will be just above and below the x-axis or below the x-axis. So what we do is, we have something called as a clear analysis of the three different situations. Number one is that when it has got two distinct roots, means the graph cuts x-axis at 2 points like this or like this. Third case that we have to discuss is, which is possibly like where the graph is just basically touching and going the x-axis. Now in such cases, what happens is that there is only one number that you can see where it cuts the x-axis, but whenever you see that it is touching the x-axis, this situation is called as repeated roots. Repeated roots. So in this case, what happens is that, let's say, when your b squared minus 4ac component, if your b squared minus 4ac becomes 0, at that point, what you'll have is, you'll have x equals to negative b plus or minus root of 0 over 2a. So your answer basically is negative b plus or minus 0 upon 2a, which eventually turns out to be negative b over 2a itself. So this is also considered as equal roots, because both the answers will be negative b over 2a. So as a main summary of it, for any quadratic, any random quadratic, you will have two distinct roots. Now, this is a mandatory situation which you need to remember. Two distinct roots where your graph is basically cutting x-axis. In that context, your b squared minus 4ac, this is referred as discriminant. B squared minus 4ac is referred as discriminant. In some places, you'll find being used like with the triangle notation. So delta is equals to b squared minus 4ac. This is referred as discriminant. For any quadratic, you can find discriminant. But this will decide how many roots it is cutting x-axis at. So if b squared minus 4ac is greater than 0, it means that x-axis in the graph, they're going to cross each other at two distinct points. When you notice that b squared minus 4ac is less than 0, graph will never meet, graph will never meet x-axis. So in that case, your graph will be above or entirely below the x-axis. And the last case is, if your b squared minus 4ac is equals to 0, then the graph will touch and go at x-axis like this. So this is the basic concept. This is the basic rule that we have. Let us take some questions in order to basically understand how to apply this. So the next part that we have is basically to actually cross-check this model that we have done so far. So I'm just taking some straightforward questions, and then we're going to figure out how many solutions does that equation have. So let's say I have got 2x squared plus 3x plus 2 equals to 0. And I want to check, without solving this equation, I wanted to check how many roots or how many points does this graph cut x-axis. So b squared minus 4ac, when I find out, which is your discriminant, so 3 squared minus 4 times 2 times 2, b squared minus 4 times 2 times 2. This, if I look at, which is 9 minus 4 twos are 8, 8 twos are 16. So that is coming as negative answer. 9 minus 16 is negative. So when I'll graph this quadratic, it will be not cutting x-axis at any point. So what does it mean is that basically your graph is entirely either above x-axis or below. Below there is no question, because if I have below x-axis, the graph must be like this then. And at that point, your coefficient of x squared will become negative. So what we have is the graph possibly will be, in this case, will be hanging up in the air with zero solution, with zero roots. Number two is, if now let's take another example basically now where we have got, let's say second example is 4x squared minus 3x and minus 2. Now, when you want to find out how many points this graph is going to cut x-axis, or it's going to cross, it will have number of roots. What you do is you find out the discriminant, which is b squared minus 4ac, and it'll be negative 3 squared minus 4 times negative 2. You don't need to solve the entire equation, because as we discussed, that this discriminant decides how many points the graph is going to cut x-axis. So for this part, b squared minus 4ac is more than 0. For this part, b squared minus 4ac is less than 0. For this part, b squared minus 4ac is actually equals to 0. So this is something which will be now coming as positive 9 and positive 32, which is coming as 41, which is positive number. So in this case, when you sketch the graph, it is going to cross x-axis at two distinct points. So it'll cut x-axis at 2 points. Now, let's take a case where it touches the x-axis, maybe like negative x squared, negative, let's say 4x, and maybe negative 2, or plus, let's say negative 4. When I do this question, what you will do is, if I do b squared minus 4ac here, now you'll notice that this is negative 4 squared minus 4 times negative 1 times negative 4, because a is negative 1, b is negative 4. So that's going to be 16 minus, this is going to be 3 minuses here, so minus 16. That is going to be giving you answer as 0. So 16 minus 16, answer is coming to 0. So in this case, you'll notice that the graph is actually touching the x-axis, something like here or like here. Obviously, like you can see that coefficient x squared is negative, so it will be other way around, which is opening downwards parabola. So this is the basic interpretation of how to use the discriminant to figure out how many points the graph is going to cross x-axis. Okay, so in this set, what we have is first we got to set this in standard form. So negative 4x, negative x squared plus 4x. And obviously C here is 0. So when you do b squared minus 4ac, you'll notice that it'll be 4 squared minus 4 times negative 1 times 0, which is 16. So since your discriminant is coming positive, here it is going to be this first situation. It means that graph of this will cross x-axis at two distinct points. So that is the meaning of this. Now the second one is 1, 2, and negative 3 are the values of a, b, c respectively. So you have b squared minus 4ac, which is going to be 2 squared minus 4 times 1 times negative 3 is going to be 4 minus, this is going to be positive, so 12, which is here. So this is going to be negative 8. So this is nothing but, this will be the value that is negative, which is, I mean, this will be positive. So this means that the discriminant here is positive, so it will cut the x-axis at two distinct points. For the third equation that we have here, so when you find the discriminant for this equation, b squared minus 4ac, it's going to be negative 5 squared minus 4 times 3 times 10. So that becomes 25 minus a number obviously higher than, so it's like close to 120. Obviously, this will be less than 0. It means that the graph will be above x-axis or below x-axis in this particular case. So graph will never meet x-axis in this case. Since coefficient x squared is positive, it will be a happy face graph, which means something like this. The last one, let's do it, which is b squared, which is 8 squared minus 4 times 2 times 8. So, which is coming to 0. So this means that in this case, the graph will touch the x-axis or meet the x-axis only once. So that's how you find out at how many points the graph crosses the x-axis or how many roots will you have. So now when you have something which is basically in terms of the straightaway equations given and you want to look at how many points the graph is going to cross x-axis, that should be okay. But now the major type of question that are assessed in the exams are like where you are given a quadratic with certain unknown or certain constant. Now, for example, they'll give us that, okay, now 3k x squared plus 4kx plus 7 equals to 0 is a quadratic. Now, this is not a quadratic with certain fixed coefficient. What you can do is you can change the values of k based on what you need, like how many roots do you want, at how many points you want to make it cut x-axis. So that will be decided by the k value. Now, what we are supposed to do is the questions might be structured as like, okay, find at find the values of k, find the values of k such that this equation, such that the given equation has two distinct roots. So the given equation has got two distinct roots. So the thing is that here what we'll have to do is, simple thing that they're saying is that find out the values of k such that it has got two distinct roots, means first you find out the discriminant. So your a value is 3k, b value is 4k, and c value is 7. So now what I'm going to do is I'm first going to find out the discriminant with these values. So the discriminant will be b squared minus 4ac, which is 4k the whole squared minus 4 times 3k times 7. So this is going to be 16k squared minus 4 3s are 12, 12 sevens are 84, 84k, 84k that has to be higher than 0. Now this, since they are saying distinct roots, they clearly said now it goes into this category for which the discriminant is higher than 0. So if discriminant is higher than 0, it will have two distinct roots. So now when you get certain inequalities like this, the quadratic inequality. Now, since we have done uh, quite a bit of questions on the quadratic inequality, what I'm going to do is I'm just going to quickly show how to get the answer from here. Lots of times, what mistake students do is that they'll say, okay, they can just take factors common, or they just bring 84k this side, so like 16k squared greater than 84k, and then they cancel k and k, and then k is greater than 84 over 16. That doesn't work. So don't do that. Well, rather than doing that, what we're going to do is we're going to understand that this is a quadratic inequality, and we're going to actually sketch this graph, or you can draw the sign diagram for this. So what we're going to do is we're going to do 16k squared minus 84k equals to 0 first. Don't take k the other side and cancel out k. Rather than doing that, you take k common here. So k will be 16k minus 84, which is equals to 0. So I get k as either 0 or k as 84 over 16. Now, when I do 84 over 16, you can simplify it like if you want, like this is nothing but 42 over basically 8, which can be further simplified as 21 over 4. So the roots of this quadratic that you have here, they are 0 and 21 over 4. Now, after the step is you're going to put these numbers on number line. Now, 0 and 21 over 4. Now, I have to figure out what will be the numerical sign in each interval, that's what is sign diagram. So now what I do is, since I already know the roots of this equation, which is 16k squared minus 84k, and what I can see is that coefficient of k squared is positive. Now, if coefficient of k squared is positive, obviously the graph will be a happy face graph. So this is going to be the graph something like this for this particular discriminant. Now, if you look at where is the graph negative, like how do I fix up the signs in each interval? So any part which is below x-axis, that's your negative. So if you look at the part of the graph, this part of the graph is below x-axis, so that's your negative. So here when you do the sign diagram will be negative. Then what part of the graph is above x-axis? Now, if you look at here, basically the part that I'm highlighting with green color, which is here, this and this part, which is positive. So when you look at the y values being positive here, so in this case, the sign is positive here and sign will be positive here. So other way you could have done was taking values in each interval. Now, for example, here I could have taken 1. If I take 1 and I plug out here, let's say 16 minus 84, it has to be negative. So 16 minus 84, negative. If I take here, maybe let's say 10. So if I do 16 times 10 squared minus 84 times 10, you'll notice that that value will come positive. So that's why this is positive here. Then again here you could take minus 1. And if I take minus 1, it'll be like 16 times minus 1 whole square is 1. And minus 84 times minus 1, that's your positive 84. So that's why the signs is positive, negative, and positive. Now, what you do is basically you have to figure out what's the correct range of k values. Now, still we are not done. Now, what we are looking forward is to find out where it is higher than 0, more than 0. Now, it means that where it is positive. Now, where do you see the sign diagram to be positive is basically in this range, which is here and here. So, if I give my final answer, if I take any k values that are in the range k greater than 21 over 4 or k less than 0, you are going to have two distinct roots. It means that graph is going to cross x-axis at 2 points in case if you pick up any k values that fulfill this inequality. Now, what does it mean? If I take k as, let's say, minus 1, if I take k as minus 1 and plug here, at that point, whatever resulting quadratic you will get will have 2x intercepts. It means that it will cross x-axis at 2 points. So here's another example where we will be basically working on the discriminant. So let's say the quadratic is y equals to 2k plus 5x squared plus kx plus 1. They're saying that it does not meet the x-axis. Now in the question itself is specified that it does not meet the x-axis. Now, what thought comes to our mind is if it does not meet the x-axis, the quadratic is going to be either above x-axis or below x-axis. Now, when you're solving for discriminant in this case, is it has to be less than 0. So this, if discriminant is less than 0, then only you'll be able to solve for how many points it is cutting the x-axis at. So now what we do is we first find out the discriminant. So a is nothing but 2k plus 5, b is k, and c is 1. So it's important that you collect the values very carefully. So a is this, b is k, and c is 1. I mean, b is this, and c is 1. So when you're finding discriminant now here, so b squared minus 4ac will be basically k squared minus 4 times 1 times 2k plus 5, which is k squared minus 8k minus 20. So get k squared minus 8k minus 20, now less than 0. Now, up till this step, you notice that, okay, whatever we did, we forget about this now. What we have is, now we've got k squared minus 8k minus 20 less than 0. Now, what you're going to do is, you're basically going to find out the roots of this equation first. So k squared minus 8k minus 20 equals, the moment you get a quadratic inequality, you try to draw sign diagram. Otherwise, your answer might be wrong. So k squared minus 10k plus 2k minus 20 equals to 0. So k minus 10 plus 2k minus 10 equals to 0. So get k is 10 or k is negative 2. So now at these two situations, now what we have to do is, with these two numbers, we have got now k is negative 2 or k is 10 here. Now I'm going to sketch this quadratic. Okay, so I'm just going to sketch how does this quadratic, because you already got the roots. Coefficient of k squared is positive here. So I'm just going to sketch this quadratic so to get the sign diagram much more faster. So here it will be something like this. This is the discriminant sign. This is not for this equation. This is for my discriminant. So now you can see that part of the graph where it is below x-axis is here. That is this part. So in this case, this part is negative. So here it will be negative. Above 10, which is here, you can see it's the part of the graph is above x-axis. So it's positive. And here it is above x-axis, so positive. So now when you find out the value of k, okay, so there we have to find out where it is less than 0, means where it is negative. So less than 0 is always negative. So you can see that the graph is less than 0 between this to this. It's below x-axis between negative 2. So k will be between basically, k is negative 2 until 10. So if I take these k values, now for example, I take, let's say k as 5 and plug here. So it'll be like 2 times 5 is 10. So 15x squared plus 5x plus 1. This will not meet x-axis at any point. So uh, when you're finding out the discriminant, it has got some significance. And the resulting quadratic, as you can see, that if you find the discriminant for this, it will be negative. So this is how you find out the basic questions on discriminant, solve using linear inequalities or like quadratic inequalities. So this is one of the most important part of the quadratic for any particular course.